So today we are starting chapter 9. We did the square root method before break, and we'll refresh our memory on that later. But what we'll do here is today we're solving quadratics that can't factor. And we're doing it by a process called completing the square. And here's something I'd like you to circle because it's kind of early in the morning. To complete the square, there's one rule, dude. There's only one way you can do it. Remember, like our normal standard form of a quadratic, ax squared plus bx plus c like equals 0. This a value right here has to be 1. So please circle that, you know. To complete the square, there is one basic rule. The a value has to be 1. Then what I got is some like bonus rules to like make this an easier process. Because completing the square is not the only way to solve quadratics that won't factor. It is one way that works really nice sometimes and is pretty ugly some other times. So here's what we got to do. If they ask us to like complete the square, that's also short for complete the perfect square trinomial. Remember those bad boys before break, the perfect square trinomial, where the first guy was a perfect square, the last guy was a perfect square, and the middle term was twice the product of their square roots and all that stuff. So here's what we rock. They just got an expression here, so we're not going to solve it. So is the a value 1? Yes or no? Cool. Follow these steps right here. All we got to do is this b value, let's take half of that. The b value is 10. What is half that b value? 5. That's phase 1. And then phase 2, square that number. What is 5 squared, baby? 25 goes in this blank right here. And that is the number that just turned that into a perfect square trinomial, a.k.a. completed the perfect square trinomial. So they ask us then to factor this guy. I know I said we're not factoring this chapter. Well, when you turn it into a perfect square trinomial, now we made it factorable. So remember, it's been a while. I know it was spring break. So we do the square root of the first guy. What would be the square root of the first guy? X. The square root of the last guy? 5. And the sign from the middle would be a plus, quantity squared. Remember, if you took twice the product of those guys, shouldn't you get 10x back in that scenario? So that worked. So we turned it into a perfect square trinomial was the job. We are completing the perfect square trinomial, but mathematicians just call it complete the square in that case. So let's try that again. How do we do it? A's got to be 1. Is the a value 1? Sure is. Now we take half the b value and then square it. Let's do that in 2 moves. What's half the b value? 7 squared, 49. Cool. Now, that guy right there is a perfect square trinomial, so we can factor him. He will be square root of the first guy, square root of the last guy, and sine from the middle, quantity squared. Yay, precious memories from 2 weeks ago. All right, so let's try that again. Can we complete the square on this? Is the a value 1? Like if the a value is not 1, we can't do this move, right? So the a value has to be 1. So since the a value is 1, to complete the square, we're going to take half the b value, which would be how much? Not quite 2. It would be negative 2. Are we with me on that? And then square it. What is a negative 2 squared? Turn out to be positive 4. Are you with me on that? So positive 4. And here's a cool little fact, Jack. This number right here will always be positive because isn't something getting squared in there, right? So that's why in front of it you always have a plus. Right? So let's factor that bad boy. It would be the square root of the first guy, the square root of the last guy, and then the tricky part is that sign from the middle, right? The sign from the middle, quantity squared. How do you feel about this so far? Not too shabby. Number 4 will also not be too shabby, so I'll let you and a neighbor give that a shot. Can you fill in the blank, right, with half the b value squared? All right. Give you a choice. Did you put in there 4, negative 4, 8, negative 8, 16, negative 16, 64, or negative 64. Those are all numbers that I usually see pop in that one. Like, what do we got? What do we got? What do we got? 16. Where did I get 64 from? 8 squared instead of like, you got to take half of it first, right? And then where I got 4 from is just like I forgot to square it in that case, so it's going to be a positive 16. Are we okay with that guy? All right, so let's factor that bad boy. Check yours with mine. See what you got. And like, tell me the truth. We've done 4 problems. Is completing the square that difficult so far? Nope, until we get to number 5. What is different about number 5 compared to 1, 2, 3, and 4? Is the a value 1? Yep. What is different? The b value is what? Well, I know it's 5. What's so weird about 5 compared to 10, 14, negative 4, negative 8? What's so weird about 5? It is odd, right? Here's some rules. We can't use decimals either, baby, because we have to take half of it, right? So here's what we're going to do. We're going to write it down like this. Isn't that half your b value? I'm just doing a little bit of scratch work to let my brain work, right? I need half the b value. I don't care that it's 2.5. We're not going to use 2.5. Are you with me on that? We're going to use 5 halves. But that's just half the b value. Don't we need to square that, right? If you know what 5 squared is, and you know what 2 squared is, you know what 5 over 2 squared is pretty darn easily. 5 squared is 25. 2 squared is, so what's 5 over 2 squared going to turn out to be? 25 over 4. Ew, right? Thumbs down to that. Not hard. Thumbs down to that. I don't like it, right? I didn't like that because I got fractions back. We can still factor it, so here's what it'll be. Who's the square root of the first guy? X. Who's the square root of 25 fourths? Again, it's not that ugly because both of them are perfect squares, right? So who's the square root of 25 fourths? 5 over 2. And then I need the sign from the middle. But yuck, bro. That kind of sucks when b is odd, right? On the next one, is b an odd number again? Yep. So we're going to get fractions back on that. So I'm going to just kind of jot down half of that to be like 9 over 2. And then let's square that. Just take 9 and square it, take 2 and square it, and put it as a fraction. How do we feel about the number that I put in the blank of 81 fourths? Cool. Factor it. And then, since we are advanced, I know it is kind of like our first day back from spring break, but let's see if we can notice something cool about this. Boom, 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 boom. There's an even shorter way to factor these than square root of the first guy, square root of the last guy, sign from the middle. See if you can notice what's true about those pink numbers that I highlighted. Discuss with a neighbor. What do you think? What do you? It's okay if you didn't notice it also, but what do you notice? Isn't this half your b value, right? What's half the b value here? Positive 5. What's half the b value here? Positive 7. Half the b value here is negative 2. So when we're completing the square, remember a's got to be 1 every time. So like this is always going to be 1x squared. That's always going to turn out to be x, or whatever letter they use. Sometimes they use y's or z's or whatever, right? And then it's going to be with half your b value in there. So that's kind of neat. Why didn't we solve any of those, though? Why were none of those solvable? They're not equations. Those are just expressions. That was just learning how to complete the square. So here it is. Here's our first quadratic equation, where obviously the instructions tell us to complete the square, but I'm going to try to frowny face factor it, or easy factor it, or whatever, right? Is the a value 1? Sure is. Can I find 2 numbers that multiply together to be negative 7? But add together to be negative 4. Here's 2 numbers that multiply together to be negative 7. Either negative 1 and 7 or 1 and negative 7. Isn't that the only possible combos, right? Do any of those add up to be like negative 4? So could we find 2 numbers that multiply together to be negative 7 and add together to be negative 4? Not going to happen. So this is not factorable. But what we can do is still solve it. And if you remember back from before break, like this is going to make a parabola if we graph it, right? You remember that crazy thing? Hey, which way would this parabola open? Would it open up or would it open down? Wouldn't it open which way? I don't know why that happened. It would open up, right, because isn't the a value positive? Do you think it's going to cross the x-axis? Like, you know, would a parabola that opens up, is it very likely to cross the x-axis, yes or no? I mean, it doesn't have to, right? It could be that second one, but is it very possible? What we're about to find are the x-intercepts. That's kind of the point of this whole thing, is where this guy crosses the x-axis. I know we just barely dipped into that last chapter, but anytime you solve a quadratic, you're letting y equal 0, and you're finding the x-intercepts in that scenario. So how will we do this one? Well, there's only one way possible, and that is to complete the square on it. Rule: a has to be 1. Is the a value of this guy 1? Yes or no? Yep. So what we're going to do is get this ready to run to complete the square. It's kind of elementary, but it works, man. I call it set him up with blanks in this scenario. So here's our quadratic. Just follow my lead, and it'll get easier as we go. X squared minus 4x. And then you see this minus 7 right here? I need to move him over to the other side. How do I move that minus 7 over to the other side? Add 7. But before we do that, we're going to do this weird elementary trick that Miss Kinderconnect taught me long time ago by putting a plus blank with that guy right there. So we're going to put a plus blank, and then here's my equal sign. You told me I wanted to move that minus 7 over to the other side by adding 7, so I did that. And then here's the weird move. If you're going to add something to one side of an equation, don't you have to add it to the other side of the equation to keep it balanced, right? Like I said, just hang with me. This is kind of a weird thing, but I'm trying to complete the square, so I call this set him up with blanks. You got all the stuff with the x's coming first with a plus blank. Then you move all your constants over with another plus blank. And I'm going to go back here. How did you feel about filling in that blank? See, I had that set up for you. Do you see how I had a plus blank with that? How do you feel about setting up that blank right there? Don't you just, for this guy right here, need to take half the b value and square it in that case? So what is half our b value? -2. Square that. What would you get? 4. So here's what we just did. This 4 turned that left side into a perfect square trinomial, baby. That is awesome. But rules of algebra. If you add 4 to one side of an equal sign, don't you have to add 4 to the other side to keep this thing balanced, right? So that's why we set up a plus blank on both sides. Now, check this out. This is awesome sauce. That is a perfect square trinomial. Let's factor it. It'll be square root of the first guy, square root of the last guy, sine from the middle, quantity squared. Or, as we learned just a few minutes ago, it's x and half your b value in parentheses, quantity squared. Cool? Now, over there, equals 7 plus 4. I think we could add those together. Those are like terms. What's 7 plus 4? 11. How do you feel about what I have done? It's weird, right? You know, but hang with me. Now, remember old Mr. Fonestill's crazy trick of if you get parentheses, you can take like a, please don't scratch it out, but you can take like a blind eye to what's in parentheses. Isn't there something like squared all by itself on one side of the equal sign? I would like to get rid of that square. How do you get rid of that thing being squared? You're going to square root both sides. So I'm going to square root this, and I'm going to square root this. And what does this square and this square root do to each other? Cancel. X minus 2 is coming down, and yep, it's been a few days since we've had math, but over here, first of all, is 11 a perfect square or anything like that? So it's going to be nasty. These are supposed to come out nasty, because if they came out nice, we could have factored them. Everything we factored last chapter was integers or like rational numbers. Sometimes you get some fractions, but it came out nice all the time. This is not, and don't forget, we need a plus or minus in front of that bad boy. Cool? And don't let the ugliness of that square root of 11 like scare us. First, can that simplify square root of 11? Is there a perfect square that goes into 11 evenly if we work backwards? Nope, 9 doesn't go into it evenly. 4 doesn't. 1 doesn't count. So now we're just trying to get x all by itself. Here it is. There's a minus 2 hanging out with it. How do you get rid of minus 2? Add 2 to both sides. We'll put it first. And how do you feel about 2 plus or minus the square root of 11? There are two different answers there. So for the first few of them, we're going to write them out. There's 2 plus the square root of 11, comma, 2 minus the square root of 11. That's how you'll type them into homework. You'll separate them with commas. Weird. That's only one example of those. We completed the squared on it. So let's try that again. And here's the thing. Please believe me that we're going to set them up with blanks. You might think you don't need the plus blanks. I'll wager that we probably need the plus blanks, right? So to complete the square, we want to set them up with blanks where all the stuff with the x's are on one side of the equal sign and all the numbers are on the other side of the equal sign. Isn't it kind of like that already on this question? So let's just set them up with blanks. So x squared plus 10x plus blank will equal negative 6 plus blank. If you add something to one side, you got to add them to the other side. And then we get into our comfort zone, filling in the blank. Remember, the a value has to be 1 for this to work, which it is. The number in front of x squared is 1. So half your b value squared goes in the blank. Fill in the blank. What you got? 25. Are you cool with that? So that's phase 1. Set them up with blanks, and then fill in your blank. Phase 2, the left side is a perfect square trinomial. So factor him. In these cases, it'll always be x and half your b value, quantity squared. And then go ahead and add the other numbers to the other side up. It's just arithmetic. You got like negative 6 plus 25, which would be how much? 19. And you also see, I kind of didn't mention it, that we got rid of the squared on the x. Like, isn't that the whole point, is like to not have the x being squared anymore? That's why we're going through all this jumbo here. So it is a quantity squared all by himself, right? What do we do to get rid of that square? Square root both sides. Radical. Yep, put a radical around it. Square root both sides. So it'll be the square root of that guy. Let me get rid of that block. Square root both sides. And then don't those cancel each other out. And don't forget your plus or minus. Then I got to see if that square root can simplify. So is there a perfect square that goes into 19 evenly? 25 is too big, right? You know, so working backwards, anything that goes into 19 evenly? Nope. So now let's just get x by itself. And I'm going to make a mistake. I'll make the most common mistake. Tell me why this is wrong. What did I do wrong? I forgot to subtract the 5 over. Like, it's amazing how we get so far and do such an awesome job, and then the most basic thing is you have to subtract 5 instead of add 5 over. Still weird. It's only 2 examples, right? We're okay with this? You know, let's try another one. How do we want to solve this? Complete the square. Why? Because they tell us to. 2, because this can't factor. I cannot find 2 numbers that multiply together to be negative 9 and add together to be negative 2, right? It's not going to happen. So can we set them up with blanks? All the stuff with the x's coming first with a plus blank. Move your constants over to the other side with a plus blank. That's probably a big, oh, my bad. It's got to become a positive 9, right? You had to move that over there. Cool. Now for the easy part, filling in the blank. Half the b value squared. Tell your neighbor what you put in the blank. It is sort of the most brain fartiest one of them all. It is a negative 1 that needs to get squared. It's not 2, right? What's negative 1 squared? It is 1, right? It's positive 1. Cool. Now factor the perfect square trinomial. It's always x and half your b value for these guys. So make sure you had a minus 1, not a plus 1 in that spot. And then I added my 9 and my 1 together. And then I can now square root both sides. Can the square root of 10 simplify? There's not a perfect square that goes into that evenly. So. 1 plus or minus the square root of 10. I think I forgot to write that as two answers on the last one, so we'll do that again. 1 plus the square root of 10, 1 minus the square root of 10. Just to show you, like, what that is, 1 plus the square root of 10, like, would you believe, is just a nasty decimally number in that case, you know, and like 1 minus the square root of 10 is also. That's where this parabola would cross the x-axis at these weird decimally-like places, you know. Not everything in the world comes out nice, you know. So when you graph the parabola, it crosses the x-axis in two really weird decimally places in that case. So let's try that again. Let's complete the square, set that guy up with blanks, and show your neighbor what you wrote. Did I have to move that negative 36 at all, or is it in the correct place? It's already in, like, I want all my x's on the left and all my numbers on the right. So x squared plus 14x plus blank equals negative 36 plus blank. You see, it was already ready without the blanks. Fill in the blank and factor. 49, right? We cool with the 49? Half the b value squared. And then, what is a negative 36 plus 49, baby? 13. Let's start talking about some stuff because we're smart, right? You know, what kind of number is 13? Say, not a perfect square. What kind of number is 13? It's nasty, right? It's not a perfect square, right? That's how you know that this isn't factorable. Like, if you get a perfect square right there, you're just like, oh, man, I could have factored this. I would have been able to find two numbers that multiplied together to be this and added together to be that. So we're on the right track. So then we'll do the square root of both sides. If you would like to stop doing this, you're welcome to, these blue radicals. Like, if you don't want to do that to both parts, you don't have to. Most people still like to do it, but you could just do this. It's going to be x plus 7 equals plus or minus the square root of 13, right? It's up to you. You know you. You do you, baby, right? You know. But I think for the most part, most of us need to tell ourselves, okay, I'm square rooting both sides by putting those two red radicals. Right? And then the square root of 13 does not simplify, so there we go. There's our two answers, negative 7 plus the square root of 13 or negative 7 minus the square root of 13. I didn't want to completely talk us through this process because it's just so weird, but I think our comfort level is better now. Are we cool with that? So now I got to talk us through it. Are we on to the back side? See, we would stop if it wasn't for weird things to happen because I think we get it. But why has it been so nice? Has the a value been 1? Yes or no? Yep. And what kind of number is the b value? Even or odd? It's been even every time. Hasn't this been pretty okay? Weird, but still pretty okay. So let's try it again. First of all, is the a value 1 on this guy? Yes or no? Is the b value an even number? This shouldn't be too bad then, right? Let's set him up with blanks. Let's set him up with blanks and complete the square on him. The 9 is in the good spot. I don't need to move him over or anything, right? Don't need to do that. And just make sure you have filled in the blank properly. Half the b value is negative 6, right? When you square that, you get a positive 36. Then we shall factor that guy. And now, 9 plus 36 is 45. The larger that gets, the more likely it is we have to simplify the radical. Because isn't that our next move, to square root both sides, right? So we'll square root both sides, and my friends, there is a perfect square that goes into 45 evenly. Work backwards and find that perfect square that goes into 45 evenly. So 49 is too big, so if I do 45 divided by, like, who am I at, 36, does that come out nice? Nope. I mean, it's not horrible, but I need to get a whole number back, so it's not nice. 45 divided by 25, definitely no. 45 divided by 16, does that come out nice? Nope. 45 divided by 9, does that come out nice? Yes, it does. So we kind of had this messed up on the test that we need to simplify this into two radicals. The perfect guy comes first, my friends. The perfect one comes first. Who was the perfect square that went into 45 evenly? 9. How many times did it go in there? 5. The reason why we want the perfect square to come first is because that's the part that can clean up. We all know what the square root of 9 is. What's the square root of 9? It is 3, so that's why we want this to be plus or minus 3 square roots of 5. Like the square root of 5 is just a nasty boy, but we broke him up. So I'm going to bring the rest of that equation down just to kind of keep it on a level playing field right there. And now I'll solve for x. How do I solve for x? I'm going to add 6 to both sides. 6 plus or minus 3 square roots of 5. So now here's the question of the day. I'm going to do the two separate answers. I'm going to do the plus part. So it's 6 plus 3 square roots of 5. And I'm going to do the minus part, 6 minus 3 square roots of 5. And here's the question of the day. I'm just going to pick on this guy. Is 6 plus 3 square roots of 5 the same thing as 9 square roots of 5? Can I add the 6 and the 3 together to get 9? Discuss with a neighbor. Remember, you can only add or subtract like terms. I will make it an easier question for you if without a highlighter. 6 plus 3x. Is 6 plus 3x the same thing as 9x? We are very more understanding that those are not like terms because doesn't the 3 have a times x with it in that case? Can't add those together. This is not a 3. This is a 3 square roots of 5. Are you with me on that? So like you cannot add those together. So that doesn't work. If it was 6 square roots of 5 plus 3 square roots of 5, then you could call that 9 square roots of 5 in that case, which is kind of weird. You treat radicals like they are variables. So that kind of wasn't that fun because we had to simplify the radical. Let's talk through 12. Is a 1? That's the only time we can complete the square. Is the a value 1? Yep. Is the b value even? So it still should be pretty pretty. Let's rock it. Set him up with blanks. Should be pretty pretty is what I said. And then fill in that blank. Half the b value squared. I believe that is a 64, is that right? Then we'll factor that left side. The left side is a perfect square trinomial because we completed the perfect square trinomial. And then, oh my gosh, 88. That will definitely have a chance of simplifying. Work backwards and see if you can find a perfect square that goes into 88 evenly. Because we do have to square root both sides next, right? So like 88 divided by 49 isn't going to come out nice. 88 divided by 36, that didn't come out nice. 88 divided by 25 is a definite no. 88 divided by 16, maybe, maybe. Nope, not quite, right? 88 divided by 9, nope. Who's next? 88 divided by, does that come out nice? Sure does, right? You see how you just got to go through the whole list, right? You know, got to go through it. So x plus 8 is going to equal plus or minus. Split that guy up into two radicals. Your perfect boy comes first. Whoever the perfect square was goes in the first radical. 4, right? And it went in there 22 times. So isn't that really x plus 8 equals plus or minus 2 square roots of 22? Yeah. And now we just subtract the 8 over. And then we got our two answers. So weird. This is pretty much the rest of your algebra life. Quadratics, quadratics. There's geometry coming too. That's different, you know. But when you get into algebra, like algebra 2, you get quadratics, you get cubics, you get all kinds of stuff. 4th degree polynomials, 5th degree polynomials, all kinds of stuff. All right, let's talk. Is the a value 1? Yep. Maybe I could like easy factor this. Like equal to 0. Can you find two numbers that multiply together to be -1, but add together to be -5? There's only one combination of numbers that multiply together to be -1. Who are they? 1 and -1. Don't those add up to 0 in that case? So cannot like easy factor this. So we're going to try to complete the square on it. Tell me, why is this going to suck? Because the b value is what? Odd. So here we go. This is all we know how to do. Boy, wouldn't it be awesome if there was a better way than completing the square. We'll do that next time, right? But today, we got to do this. X squared minus 5x plus blank equals 1 plus blank. This going to be not so nice. But here's the thing. You'll start to learn as you get more experience. We can do the cheat code. I can already go down here and tell you exactly what's going to be in those parentheses. Isn't it x and half your b value every time, right? So x, who is half your b value? You don't get decimals, my friends. Almost 5/2. It's not quite going to be 5/2. What's it going to be? -5/2, right? So I did that so I could visually see the -5/2, because what's got to go in the blank is that number squared. Right? What is -5/2 squared going to turn out to be? 25/4. 25/4. Ew! This was the easy part. Here's the hard part. Unless you're like a new kid on the block who uses their calculator to do all their fractions and stuff like that. Of course, I'm not going to take your calculators away from you, except for those blue ones that simplify radicals. You know what I mean? But we got to add those fractions together, and don't you need a common denominator to do it? So it's pretty easy. If this denominator is a 4, first of all, you turn that into 1/1, right? And you make that denominator a 4 as also. How do you make this denominator a 4? What do you need to multiply 1 by to turn him into a 4? So isn't this 4, right? If you do the bottom times 4, don't you got to do the top times 4? Isn't 1/1 the same thing as 4/4 in that case? So now you can add 4/4 plus 29/4. They will still be in fourths, right? So you have, when you add fractions, the common denominator stays. So what's 4 plus 25, baby? 29. 4/4 plus 25/4 is 29/4. Ew. Cool. Next move, what do we want to do next? Square root both sides, right? So here's a little trick. You'll learn more in advanced geometry, honors geometry, right? You know, so you'll learn more, but you can't square root a fraction. It just doesn't, it's not proper. So what you end up doing is you pull it apart, you square root the top, you square root the bottom, right? Like to have a fraction underneath of a square root symbol is not a cool thing. So to square root the entire fraction, you just do the top, you do the bottom. So over here, this is our same old story. It's going to be x minus 5/2. Don't forget we have plus or minus. And let's just look at these one at a time. Top, ugh, nice or nasty? Square root of 29. Nice or nasty? That's nasty. Downstairs, square root of 4. Nice or nasty? That's nice. What's the square root of 4? That's 2. So that came out pretty nice right there. Square root of 29, does that simplify? 25, no way. 16, 29 divided by 16. 9, 29 divided by 9. 29 divided by 4, so it doesn't simplify. So all I got to do is add 5/2 to both sides. 5/2 plus or minus the square root of 29/2. And nope, even though those have a common denominator, you can't actually add them together because one of them has a radical with it and the other one doesn't have a radical with it. Nice? I know we're getting a little tired. I knew it's kind of a long worksheet, but we're at that time of the year where we got to have some long worksheets. I will give you and a neighbor a chance to complete the square on number 14. So it's only been about 25 seconds, and just by listening to some whispers, they had some good questions. What are some of the questions that you asked yourselves? What's the magic rule to complete the square? A's got to be 1. What is our A value on this question? 4. So we got to problem solve this. A is not 1. A is not 1, but they want me to complete the square on it. What are our options? Divide by 4. Yep. I also heard some other people use 3 magic letters. What were those 3 magic letters? GCF. Is there a GCF of 4? That could be taken out. The true thing to do is probably take out the GCF of 4, right? Sometimes it won't be a GCF. So like, let's just pretend that this was like 27. You know, it's like, oh crap, we don't have it, right? What do you got to do then? Divide by 4. You've got to make it turn out to be 1. So the GCF would work in this scenario. It is going to be easier to do this. Divide by 4, divide by 4, divide by 4. We've got to have the A value be 1. So whatever that A value is, if he's not 1, divide every term by that number. So this would be 1x squared minus 4x equals 6, correct? Now you can complete the square on that. And will it come out nice? Is the B value even as well? Should come out pretty nice, right? Those fractions are yucky. So why don't you pause the video and see if you can complete the square on this guy. Yeah, the number in the blank is 4, right? -2 is half the B value. When you square it, you get a positive 4. So x and half your B value. That'll equal 10 over there as a quantity squared. Then you square root both sides. And the square root of 10 doesn't simplify. So bada boom. And then you could write that as 2 separate answers. 2 plus the square root of 10, 2 minus the square root of 10. And I do feel that we understand what we're trying to do. You know, we might make some mistakes, but there is only one question left. It is there for a reason, right? So I would like to do it. But before we get there, are you cool that we had to divide by 4 because the A value was 4, and it's like, got to get rid of that, right? So that kind of sucked, but it actually wasn't that bad because 4 was common to everybody. So let's try again. Is the A value 1, yes or no? Yes, so that's nice. Is the B value even? Yep, that'll be nice. Let's complete the square on this and see what happens. So set them up with blanks. And then fill in that blank. Little help. Who should go in the blank? 9 or -9? It's always a positive number, so 9. Nice, nice, nice. Then this will be x minus 3, quantity squared. Yep. And then when we add those two numbers together, I hope you realize something special is about to happen. You have to add 16 and 9 together for me, though, to do that. What is 16 plus 9? That's very different than what we've done before. Why is that very different? Because that's a perfect square. Here's what this means. We should have factored that. But it's too late. We've already went through all this work. We might as well finish it. But I would be able to get this equal to 0, x squared minus 6x minus 16 equals 0. I would be able to find two numbers that multiply together to be -16 and add together to be -6, right? It's 2 and -8. Are you with me on that? So I could have factored this. But we went this far, we might as well finish it. So what's my next move? Square root both sides. And this is why we have to be smart. This is going to come out real nice, right? Because that would be x minus 3 equals plus or minus. Do not write the square root of 25. What is the square root of 25? It is 5. Cool? And then when we add 3 to both sides, I know we're still very new at this. It is going to be 3 plus or minus the square root of 5, but here's my question. Are those like terms? So we can actually do it. What's 3 plus 5? So x could equal 8, or what's 3 minus 5? Not 2. What's 3 minus 5? Negative 2. Why did the answers come out nice? Because it was factorable, right? It was factorable. So that was the whole point. And here, this will be something as we go through this chapter. Remember, this is only like lesson 1. There are other ways to solve quadratics, especially the ones that came out ugly today. So when would be the best time to complete the square? When this guy has both x squared and x's in it. Hey, slow down. You remember before, like when we took the test last time, I gave you questions like this, you know, like I'll just make up a quick one, like 4x squared equals 25 in that case, right? Like, is that possible to like do it a different way? Does that have x squareds with it? Is it quadratic? Yes or no? Does it have x's? Just x to the first. I know there's the letter x in there, but is it squared or is it just x? It's squared, right? So does it have x squared? Yes. Does it have x's? No, it doesn't. Could you get x squared all by itself? There's a times 4 hanging out with it. How do you get rid of the times 4? Divide by 4. X squared equals 25 fourths. Then how do you get rid of that square? Square root both sides. Wouldn't x equal plus or minus 5 halves in that case? This was called the square root method that I know it's been about 10 days since you did it, but there was only like 5 questions on homework that you did, and you got them done in less than 5 minutes because it's very simple to solve a quadratic equation when there's only x squareds in it. That's called the square root method, SRM, square root method. Today, did this have x squared and x's with it in the same equation? So we can't do that. There's no way you could get x squared by itself without there being an x over there, so we completed the square on it. So first of all, that's when we're going to choose complete the square. It also should not be factorable. Dude, if we could factor it, I would do that. Like, I think finding those two numbers, like 2 and negative 8, was a lot faster than going through the complete the square process. So if we can factor it, we're going to do it. And then what do we want to have? Well, this has to happen. Would you agree that A has to be 1? What do we love to have happen, though? B to be what kind of number? Even. So I know it's been a long, long day. I appreciate you hanging in there. But we need to like totally buy into talking ourselves through these because it ain't getting any easier, my friends. You know, so don't bury yourself into a hole. Learn to talk ourselves through it. The only thing that I'll help, I shouldn't say the only thing, things I got to help you with is stuff we learned before spring break because it's been a while. You know, it's been a while. So there might be some square root methods on our homework. Check those out. All right, let us know if you have any questions. Have a good one.